Dividing polynomials. There are two different methods for dividing polynomials, and the first method is long division. So before we divide polynomials by long division, let's review long division you learned in elementary school, because the steps are the same. So let's divide 4,392 by 7. We'll set it up, and then remember you look at the 7 and the 4. 7 won't divide into 4, so you go a little bit farther. 7 into 43 is 6. So the 6 goes on top, and think about the process. When you put the 6 on top, then you multiply the 6 times the 7, and then the next step is to subtract. Now we bring down the 9 and start all over again. 7 into 19 goes twice. Multiply the 2 times the 7, which is 14. Subtract. Bring down the 2. 7 into 52 goes 7 times. 7 times 7 is 49. And subtract. And we have a remainder of 3. Now, when you were in elementary school and you learned to do long division, you learned to do remainders 3 different ways. Sometimes it was 627 and then the letter R and the 3. Sometimes you put a decimal after 4392 and filled in zeros and kept on going. And then the third way, which is how we're going to do it with the polynomials, is you wrote the remainder as a fraction. So it's the remainder, which is 3, over the divisor, which is 7. Now let's try a polynomial, x cubed plus 27 divided by x plus 3. So the x plus 3 goes on the outside. Now, after the largest exponent, which is a 3, all of the smaller exponents must be represented in the division problem. So this polynomial has an x to the third, but an x squared and an x to the first are missing. So we'll have to fill in zeros for those. So we have x to the third plus 0x squareds plus 0x to the first, and then we have plus 27. Now to start this off, you look only at this x on the outside and the x cubed. And you have to think, what do you multiply x by to get x cubed? And that would be x squared. And I always write my numbers on top to match with what's just below it. What I'm saying is I put the x squared over the other x squared. And then you're going to multiply out the x squared times both the x and the 3. So that will give us x cubed plus 3x squared, and then we subtract. Here's where most of the mistakes are made. You have to be very careful. The subtraction goes to both the x cubed and the 3x. So 3x squared rather. So it will be a minus x cubed and a minus 3x squared. X cubes would cancel. 0x squared minus 3x squared is negative 3x squared. And you bring down the plus 0x and then start all over again. So I look at the x at the top. I look at negative 3x squared. What do you multiply x by to get negative 3x squared? Negative 3x. And then you're going to multiply that back out. That would be negative 3x squared minus 9x. Subtraction. The subtract affects both the negative 3x squared and the negative 9x, turning them both positive. So we end up with positive 9x, and then bring down the plus 27. And then one more time, we look at the x up on the outside and the 9x. What do you multiply x by to get 9x? That would be a positive 9. Multiply that out. 9x plus 27 and subtract, and this one has no remainder. Okay, this next one's a little bit longer. Look at the highest exponent on top, that's cubed. We have the cube, the squared, the first power, and the constant, so we're not missing anything. 2x plus 1 into 4x cubed plus 2x squared minus 2x minus 3. So I look at the 2x and the 4x cubed. What do you multiply 2x by to get 4x cubed? That would be positive 2x squared. Multiply that out. 4x cubed plus 2x squared. Subtract. The subtraction goes to both, turning them both minus. This one ends up, everything cancels. So you would want to write, because it's 2x squared minus 2x squared, you would want to write 0x squared. It helps keeps everything, all the spacing correct. Bring down the minus 2x. And what do you multiply 2x by to get 0x squared? That would be 0x's. And again, this is just to kind of hold the space. Multiply out and you have 0x squared plus 0x. When you combine all that, you just have negative 2x. Bring down the minus 3. What do you multiply 2x by to get negative 2x? That would be negative 1. Multiply out, negative 2x minus 1. Subtract. The negative affects both, turning them both positive. So we have a negative 2 for our remainder. The way you'll write your answer then, what we have on top, and we don't need to write that 0x, is 2x squared minus 1, and then you add on the remainder as a fraction. The remainder is negative 2 over what we were dividing by, 2x plus 1. And you could, if you wanted to, instead of writing plus negative 2, it could just be minus 2 over 2x plus 1. Either way is fine. Okay, let's do one more long division. X squared minus 2x plus 2. And then we're missing from the top one, we've got an x cubed, but we don't have an x squared, so we'll fill in the 0. X cubed plus 0x squared plus 6x plus 3. Now we look at the x squared and the x cubed. What do you multiply x squared by to get x cubed? That would be x to the first. So I'm going to put it over my other x to the first. Multiply out all 3 this time. X cubed minus 2x squared plus 2x. Distribute the negative. So it will become a positive 2x squared and a negative 2x. Bring down the plus 3. Then I look at x squared and 2x squared. What do you multiply x squared by to get 2x squared? That would be positive 2. Multiply that out. 2x squared minus 4x plus 4. Subtract. The negative affects all 3. So it's going to be 4x plus 4x is 8x, and 3 minus 4 is a negative 1. So my remainder is 8x minus 1. The answer then is x plus 2 plus my remainder, 8x minus 1, over what we were dividing by, x squared minus 2x plus 2. The second method for dividing polynomials is called synthetic division. Synthetic division is quicker than long division, and it's usually more error-free. However, you can only use synthetic division when you're dividing by a binomial. Like this problem is divided by x plus 1. That's a binomial because it's 2 terms. The previous problem we were dividing by a trinomial, and we wouldn't have been able to do synthetic division. So, the way you set it up is, first of all, whatever you're dividing by will be x either plus or minus some number. That number goes in a little box, and you change its sign. So it's a plus 1 in the parentheses, a negative 1 in this little box. Anytime you pull a number out of a parentheses, its sign is going to change. If it's not with an x in a parentheses, it will stay the same. Now, just like with long division, if we're missing any terms from the highest exponent down, we have to fill in zeros. And we're only putting down the coefficients. So we've got 3x to the 4th, 0x squared, 0x cubed, 0x squared, a negative 1x, and a negative 4. leave some space, draw a big line under all of it, and the very first number drops all the way to the bottom. Then you multiply it by whatever's in the box. 3 times negative 1 is negative 3, and it goes up here. And then you add. So 0 plus negative 3 is negative 3. And then you do it again. Negative 3 times the box would be negative 3 times negative 1, positive 3, and add. 3 times negative 1 is negative 3, add. Negative 4 times negative 1 is positive 4, and add. The very last number is always your remainder. So since it's 0, we don't have a remainder. Then the way you write the answer is you look at the original highest exponent, x to the 4th, and you reduce that power by 1. So my answer will start with x cubed, and these numbers are the coefficients. So we'll have 3x cubed minus 3x squared plus 3x minus 4, and no remainder. Another synthetic division. So we have x minus 4 we're dividing by, so we change the sign and put a positive 4 in the little box. Coefficients, I have all my exponents, 4, 3, 2, 1, and constant. So 1x to the 4th, negative 3x cubed, negative 5x squared, 6x, negative 3. Leave some space. First number drops all the way to the bottom. Multiply by the box, and add, multiply, add, multiply, add, multiply, and add. So now we have a remainder of 5. My original problem started with x to the 4th, so I reduce by 1, and I'll start my answer with x cubed. 1x cubed plus 1x squared minus 1x plus 2, and you write the remainder just like we did for long division, plus a remainder over what we were dividing by. Now, you're used to evaluating polynomials for given values of x. For example, if we had p of x equals 5x squared minus 2x plus 1, and we're asked to find p of 4, then what you've always done for that is just everywhere you see an x, you replace it with a 4, and you work all that out, and you end up with 73. You can also find that answer by using synthetic division. So it'll be written with the polynomial, and then they have c equals 4. That's what we're trying to find the value of. And we put the 4 in the little box. Now the 4 is not in a parentheses with an x, so we're not going to change its sign. It's just positive 4 in the little box, and then the coefficients of my polynomial, 5, negative 2, and 1. 5 drops down, multiply, and add. It's an 8. Multiply, and add. And it turns out that the remainder is the same value you would get if you just plugged in a 4 everywhere you see an x. That comes in handy when you're solving some types of graph problems. Now, the degree of a polynomial is the highest exponent, and it also represents the number of zeros the polynomial has. And the zeros are the values where the graph crosses or touches the x-axis. If we know the zeros, we can work backwards and write the polynomial. So let's think about how we normally find the zeros of, say, this quadratic function. I've got x squared plus 2x minus 24 equals 0. I can factor that, and then set each factor equal to 0, and I've got x equals negative 6 and x equals 4. Those are the zeros. So we're going to work backwards. We're going to start with the zeros, put them back in the parentheses, and multiply it out to end up with the original polynomial. When you put them back in the parentheses, always think about it's x minus your 0, because it's the opposite. The signs change, and when you do subtraction, you can think of the minus as meaning opposite. We have a polynomial of degree 4, and they gave us the 4 zeros, so we're going to put them back in the parentheses, and it will be x minus a minus 1 is plus 1, and then x minus 1, x minus 3, x minus 5. Now we've got to multiply all that out, so I'm going to put them in pairs and FOIL. The first two together would be x squared, and then the outside and inside would cancel. Last would be minus 1. For the second pair, it would be x squared, and then a minus 5 and a minus 3 make minus 8x plus 15. Now to multiply those two together, I'll do the distributive property, first with the x squared, and then with the negative 1. So with the x squared, we would have x to the 4th minus 8x cubed plus 15x squared. And then the negative 1 times everything would give us negative x squared plus 8x minus 15. Now combine like terms, x to the 4th minus 8x cubed, and then plus 14x squared plus 8x minus 15. So that's the original polynomial whose zeros are negative 1, 1, 3, and 5. We can also by acquiring zeros from the graph. So if we look at the graph we have here, we're told it's of degree 4. That means there should be 4 zeros. But when you look at the x-axis, you only see 1, 2, 3. However, when a graph dips down, touches the x-axis, but does not cross, and then goes back, that root counts double. It's called a double root. So we can see we have a 0 at negative 2, at negative 1, and then since it just touches at 1 and then goes back the other direction, 1 is a double root. We write it twice. So now it's going to be the same procedure as the previous. We're going to put those into the parentheses, changing the signs. X plus 2, x plus 1, x minus 1, x minus 1. And you can rearrange them however you want to, as far as pairing them up to FOIL them. When I do the first two together, I have x squared, outside and inside make plus 3x, and then plus 2. And then the 2 in the back would be x squared. Outside and inside make negative 2x plus 1. Now I'm going to have to do the distributive property 3 times with the x squared, with the 3x, and with the 2. So with the x squared, we will have x to the 4th minus 2x cubed plus x squared, with the 3x plus 3x cubed minus 6x squared plus 3x, and then with the 2 plus 2x squared minus 4x plus 2. Combining like terms, then our final answer would be x to the 4th, and then my x cubes together would make a positive x cubed. The x squareds, 1 minus 6 is negative 5, plus 2 would be negative 3x squared. X to the first power, 3x minus 4x would be negative 1x, and then a plus 2 at the end.